Okay, yeah. So this week's lab, it's pretty simple in comparison to other ones. You don't have to. It's just following syntax. You don't have to put a lot of thought into how the logic works, at least when you compare it to other labs that we've done recently. Um, and so here in the PDF, you can see that the syntax for how to create a macro is laid out, and a macro is kind of like a function for assembly. Um, yeah, I mean it's a pretty good analogy, I think. Um, so you you know you guys can read. That a lot of what I say will be contained within here. Um, but you start it with the keyword macro, and then you end your macro with MEND. And this so this word right here, like this is how you're gonna call your macro. And so this, to be honest, I took a look at it. I'm not totally sure. So this is actually optional, but I would keep it just because the solution has it. So make my life easier and just use um, this right here, this part right here. I think it's called a.
Hey, sorry, Justin, we can't see your
Oh,
screen.
need to share my screen. Okay, yeah. Okay, can you all see it now?
Yes.
Okay. So back to what I was talking about. Here at the beginning of the lab, um, is the syntax for a macro. And so you can see down here that um, we're giving you basically a template, and all you have to do is come in and write the two macros. So you want one macro to add add the ones in a hexadecimal number, like we've done for the past 2 weeks. And so basically, I'll make the solutions available for the past two labs. And all you really need to do is take those and encapsulate them in a macro. So you're going to encapsulate them in a macro up here, and then they're going to be called down here. And so in terms of syntax, this right here is actually optional, but I would keep it. This is how you call, this is what you use, like as per the example, you can see that that's how they're calling the macro. And it works a lot like a function. And so you can see here you have your parameters, pass them in, do something to them. And I mean, they don't really get returned, they get added into the register. Um, what else? Okay, another thing that I saw in the solution that you need to just do to make your life easier is, so this right here, this is where, I don't know the logic for the syntax, but I know that it is the syntax. You have to put this here to start your function, essentially. And so what we're going to do is we're going to encapsulate those the labs over the last 2 weeks in a function that we can call that will count the number of zeros in a hexadecimal number. And so you're obviously going to need a loop to do that. And so with your loop, I noticed in the solution something that people might have trouble with, or I don't know why it does it, but you should just do it, is it's, some example. The syntax will be like some example, and then some example dot loop. And that's like what you declare for your branch statement when you're running through your loop. And I don't think it's necessary to do it like that, but I would just I haven't had time to play with it and like break it and see if it works without it, but that's how it works. So I would just do that to make your life easier. So if you look at this example right here, let's say we had a branch statement in between this add, or in between this add and this mend, like after the add, before the mend. Let's say we have a BNE. branch not equal. So let's say we have you're going to have, it's going to say branch not equal some example like this, or like, $ some example dot loop. And then you're going to have that link up at the front too. So it'll be, you need this here just because, okay? But then you space down a little bit and then you'll have some example dot loop, if that makes any sense. And so that's the syntax they're using in the solution. I just want to make sure that y'all just do it so that we don't have any trouble in terms of like, if it turns out that, because I didn't have time to like, play with it. So turns out it might not be necessary, but I would just do it so that we don't have any trouble. Do you guys have any questions? Let me look at the chat. So yes, a macro is similar to a function. Exactly. So Tyler, who that's exactly right. It'll be B and E, and then that loop, you'll have it up at the front. Underneath, you're already going to have your one. You need to call this, and it's in terms of syntax. You should just accept it that that's the way it is. You call this. It's not really a call right there. That's just, you just put it there. Space down a little bit, and then you start writing your function. And so this right here is the meat of your function. So within that function, you're going to have, the sum example dot loop. Yeah. So if you tried doing it without it and it gives you errors, I just looked at the I just looked at the solution and it has it. So I would just do it that way. Maybe I'll do a little. I'm not sure why it requires that or how exactly that works, but I would just do it that way. Any other questions? What do you mean? So like ones counter? Yeah, you can it doesn't have to say some example. You can call it anything you want. And then I haven't looked at the expected answer, but I mean, you can just put this number into a hexadecimal converter and convert it into binary and just manually count. It shouldn't be that hard to verify if your program is working properly or not. It doesn't have to be this number, but well, actually, you should use this number. You should use this exactly the same. So I don't know what this is in binary, but it won't be hard to put this into a hexadecimal converter, convert it to binary, count the ones, and if you're getting that if it's counting it properly, then it works. Yeah, the last two labs. So I'll make this solution available for the last two labs so that y'all don't have to. You can just paste it in. You don't need to like redo it or anything. And so, basically, like it kind of explains that here. But it's so that you can use. To be honest, I need to look that up, but I would just, it's part of the template, so I would leave it there for now. Like you don't need to think about that, like why those are there, what they what they do. I need to look in the documentation, but it's some kind of like, I think it allows you to like call a unique function or something like that. It tries to explain it right here, but I don't quite really understand. But so all this code right here, you just copy. Like you don't you don't change it. You only change this code up here. Yeah, it's like the X1 in the example given. All right. Well, if you guys don't have any more questions, I'm gonna end the session then. The expected value is for what? For like the registers? So like I just said, I don't know what this number is, but it should be easy to put this hexadecimal number into a hex to binary converter, and then you can just manually count, you know, the ones in that binary to see if it's right or not. All right. Yeah, so I mean, that's what I'm saying. That's exactly what I'm saying. Like the previous labs, you did the same thing. You were loading a hexadecimal number into a register, and then you were counting the number of ones in the binary version of that. Just the same thing happening here. So you know what we can do? Got it? Okay. But you need to take that code and encapsulate it in a macro as per, you know, you need to change the syntax in the appropriate format and put it right there. And then this, so like one of your functions is going to be called count ones underscore lap. Make sense? All right. Well, I'm going to post this online, and you guys can email me if you have any questions. Y'all have a good rest of your week.